Hello and welcome to Physics Teacher. In this grade 11U functions math tutorial, I'm going to be going over reflections and inverse functions. Let's get started. Alright, so let's start by looking at this function. We have f at x equals the square root of 2 plus 2. And we're going to find its reflection in the y-axis, and then in the x-axis, and then in both. So let's start with the y-axis. How are we going to do this? Well, let's say the reflection in the y-axis, let's just call that function h of x, and it is going to be equal to f of negative x. So all we're really going to be doing is replacing our x's with negative x's, and we get the square root of negative x plus 2. Let's see what these two functions, f of x and h of x, look like on our calculator. Alright, so if we're looking at a reflection in the y-axis, let's write the original function. So we've got the square root of x and then plus 2. Okay, now I'm going to add the reflection function that we figured out. So that's going to be labeled as f2 of x, and we ended up getting the square root of minus x plus 2. All right, so that's what it looks like. It looks like you place a mirror along the y-axis and it flips the image about that axis. Now the range is still just like the original function, going to have y being greater than or equal to 2. However, we can see that the domain, whereas the original function was x must be greater than or equal to 0, this one is going to be x must be less than or equal to 0. I think that makes sense if you look at the function, because if you had a positive value of x, then you're taking the square root of a negative number. Moving on, let's figure out what our function, let's say r of x, will look like if it is a reflection of f of x in the x-axis. So to do that, we're going to set this equal to negative the function f at x. Now that negative needs to distribute through the whole function, so just to help us, let's put negative, and then the f of x, let's put in brackets. So we have minus bracket the square root of x plus 2, and then that negative is going to distribute in through that whole function, or in through the whole bracket. So we're going to have minus the square root of x minus 2. Now let's compare these functions r of x and f at x on our graphing calculator. All right, let's see what a reflection about the x-axis looks like. So we've got our original function there. So we calculated that this one would be minus the square root of x minus 2. So now it's like if we had a mirror along the x-axis, we perfectly flip that function around to the other side of that axis. Now this one, the domain is going to be the same. However, the range is different. Instead of being greater than or equal to 2, our new range is going to need to be less than or equal to negative 2. Now finally, let's do a reflection in both y and x. So let's say we have some function s of x, and that is going to equal negative f of negative x. We're doing both now. So just to be careful, we're going to put that negative and then a bracket. And then under the square root, we'll have negative x plus 2. So when we distribute the negative, we get negative the square root of negative x minus 2. So finally, let's see what this looks like compared with f of x on our graphing calculator. And finally, if we flip it about y and x, we get minus the square root of negative x minus 2. And so it looks like we flipped it about one axis and then again about the other axis. And so the domain and range are both going to be changed. The range is going to have to be less than or equal to negative 2, and the domain is going to have to be less than or equal to 0. All right, next, let's look at how to find the inverse of a function. Now, When you have coordinates, you're just switching the x and y coordinates. When you have an equation like this one, which is a quadratic equation, we switch the x and y variables and then rearrange to solve for y. So first thing, let's actually write f at x as y, because that'll be a little bit easier for us to do the algebra. So we'll have y equals 2x squared plus 16x plus 29. Next, it's a lot easier to switch your x and y variables if you only have one x variable. So we are going to have to first complete the square. So let's just quickly complete the square. We'll go over how to do this. So first I'm going to pull out a 2, because I want that coefficient in front of x squared to be a 1. So let's pull out 2 from these two terms. So we're going to get x squared plus 8x, and we'll leave that 29 alone for now. Next, look at this coefficient 8 in front of the x, take half of that, which is 4, and then square it, which is 16. And what we're going to do with 16 is inside of this bracket, we are going to add it, and then so we don't change anything, we're also going to subtract it. Now, what we have with these three terms is a perfect square. So I can write that as x plus 4 squared. Now don't forget, we still have this minus 16. And this plus 29. Then we can distribute the 2 into these brackets. So then we have 2 times x plus 4 squared minus 2 times 16 is 32 plus 29. And then we can just simplify those two constants at the end. So now we have it in vertex form. So now what I'm going to do, I'm going to go do this up here because I'm running out of room. I'm going to switch the x variable and the y variable. So we're going to have x equals 2 times y plus 4 squared minus 3. All right, so now let's rearrange and solve for y. So we'll add 3 to both sides. Then divide both sides by 2. So we have x plus 3 all over 2. Now we can take the square root of both sides. And remember, when you do this, you have two solutions. So we have plus or minus the square root of x plus 3 over 2, which equals y plus 4. And then subtract 4 from both sides. So we have minus 4 plus or minus the square root of x plus 3 over 2 is equal to y. So that is our inverse function, which we typically denote the inverse function as f to the negative 1 of x, which in this case is minus 4 plus or minus the square root of x plus 3 over 2. But let's do a couple checks. Let's graph both the function and its inverse to see what this actually looks like. And then let's determine if the inverse of this function really is a function. So we're going to get out our graphing calculator.
All right, so let's start by graphing the original function f at x. So we're going to have 2x squared plus 16x plus 29. So now we're going to input our inverse function. So we have negative 4. And then we have plus or minus. So I'm going to teach you how to do this on the calculator. This is going to be our lesson for the calculator today. It's a little bit tricky, but we're going to hit plus. Then you're going to use these curly brackets, and you're going to do 1 comma negative 1. So that's giving you the option of plus or minus. If anyone knows a better way to do this, let me know, but this is the way I know how to do it. Okay, and then we're going to have the square root of Let's throw a fraction in there. X plus 3 all over 2. Now, there's the inverse. Now, what's really cool about this is if you graph the equation y equals x, so just a straight line. Let's just look at this for a second. So I'm going to graph another function, just x. And you'll notice that your inverse is a reflection of the function along the line y equals x. Isn't that cool? However, is our inverse of this quadratic a function? No, it is not. If you were to do your vertical line test, you are seeing you're getting multiple points along our vertical line. So this is not a function. Now, there are some cases where the inverse of a function is a function. You're just going to have to check those out yourself.